Okay, lesson 1.3, we're still talking about line segments. This time we want to talk about how do we find the length of those line segments. So the first thing we should note is that there's a couple of different ways we can find length. One of them is to use the distance formula, and then we can also look at the Pythagorean theorem, which actually the distance formula is just the Pythagorean theorem disguised in a costume. So just kind of note that. I know that you have seen the distance formula before. I'm going to go ahead and let this nerdy math video give you a little rundown.
Let's start off our lesson on the distance formula by asking ourselves, what is distance? We can think of distance as a length between a starting point and an ending point, just like a starting line and finish line in a 100-meter dash. When we use the GPS, we're looking at distances between a starting point and an ending point.
Starting route to San Francisco.
Just like the drive from San Diego to San Francisco would be a distance of 502 miles. So for this lesson, we're concerned with finding the distance between two endpoints connected by a line segment. In this case, line segment CK. If we measure this line with a ruler, we can say that CK has a length of 13 centimeters.
Ooh.
And we are going to extend this idea of finding distance between points on the coordinate plane. Please note that distance is a measure of length. The words are interchangeable, and distance is measured in units. Finally, when finding distances on the coordinate plane, our tool is not going to be a ruler, but the distance formula. So let's go ahead and learn how to use the distance formula. Our first example calls for finding the length of line segment AB. Now, when we see the word length, we should be tipped off to use the distance formula. First, we're going to need the coordinates of the endpoints A and B, with A at 3, 7 and B at 7, 4. Now again, A and B are both points with X and Y coordinates. Since A is the first point, we'll give it the 1's x1, y1, and since B is our second point, we'll give it the 2's x2, y2. And now we're ready to use our formula. Let's start off by looking at x1 and x2. x2 is 7, x1 is 3, so we have 7 minus 3 in parentheses on the left side of the equation. Now we can slide that over and look at y2 and y1. y2 is 4, y1 is 7, so we have 4 minus 7 in the parentheses on the right side of the distance formula equation. And now that we're done substituting, we can begin to evaluate. 7 minus 3 we know is equal to 4. On the right side, 4 minus 7 is equal to negative 3. Now we can evaluate the exponents. 4 squared is equal to positive 16. And we're adding that to negative 3 squared, which is equal to positive 9. Remember, a negative number squared is a positive value. And we know that 16 plus 9 is equal to 25. And finally, we can evaluate the square root. The square root of 25 is equal to 5. So what we just found is that line segment AB is 5 units long. Now, real quick, if we look at AB as the hypotenuse of a right triangle, we notice that the legs of the right triangle are 3 and 4. This is your classic 3, 4, 5 right triangle. And this value of 5 can also be found using the Pythagorean theorem. So we should see that the distance formula actually comes from the Pythagorean theorem, a squared plus b squared equals c squared. For our next example, we're going to be observing a quadrilateral on the coordinate plane with endpoints W, Y, C, and M. We want to find the length of line segment WC, so we know we're going to have to use the distance formula again. Notice that W and C are diagonal from each other, so this is a diagonal of this four-sided figure. So we have to construct that line to help us visualize what line segment WC looks like on the coordinate plane. Now we can write down the coordinates of W at negative 6, 4, that's your x1, y1, and C at 4, negative 2, that's your x2, y2. In the distance formula, we can now substitute x2 minus x1 is going to be 4 minus negative 6. Then on the right side of the distance formula, y2 minus y1 will be negative 2 minus 4. So now we can continue to evaluate 4 minus negative 6. The double negative becomes a positive, so 4 plus 6 equals 10. And on the right side of parentheses, negative 2 minus 4 is equal to negative 6. Now the exponents, 10 squared is equal to 100, plus negative 6 squared is equal to positive 36. And 100 plus 36 is equal to 136. And now we just need the square root of 136, which is going to equal an irrational number. And since the question asks us to round to the nearest 10th decimal place, we'll round our answer to 11.7, the length of line segment WC.
Oh, yeah!
Please follow us on Instagram @MashupMath for free daily math tips and infographics.
Okay, so now that you've gotten a couple of examples under your belt, let's formalize that thought in your notes. So looking at this example, it says use the distance formula to find the distance to the nearest hundredth from negative 2, 3 to 2, negative 2. So that's negative 2, 3 to 2, negative 2. And I gave you a graph here that kind of has the length of the line segment that we're looking for, but it also shows you that right triangle if you wanted to use Pythagorean theorem with 4 squared plus 5 squared equals c squared, okay? But we're going to use distance formula. So remember, distance formula is x2 minus x1 squared plus y2 minus y1 squared, and then you take the square root of all of that. And so the first thing you're going to do is you're going to say, okay, here's my x1, y1, here's my x2, y2, and you're going to just substitute in, okay? So you're going to get 2 minus negative 2 squared plus negative 2 minus 3 squared. So there's your substitution. Note all the parentheses to make this possible, okay? If you leave off these parentheses right here and you go to your calculator to type this straight in, you're going to get the wrong answer, okay? So be careful of that. Then you're just going to subtract, and that 2 minus negative 2 minus a negative becomes plus, and then negative 2 minus 3 is negative 5. Notice that my negative numbers always stay in parentheses. My negative numbers always stay in parentheses. A negative times a negative is going to end up with a positive, okay? So that's going to get us 16 plus 25, which is 41. And then we take the square root of 41, and we get 6.40. Remember, this is the tenths place, it's the hundredths place. So it says round to the nearest hundredth, so that's actually what's been done here. Excuse me, if you're confused about rounding, now would be a good time to hit pause and ask your teacher to explain rounding to you, okay? So what we're saying here is that the length of the line segment AB, or the distance from A to B, same thing, is about 6.4 units, right? So because we're counting diagonal and not straight up and down, it's hard for me to say like, okay, well, here's what 6 would look like. But this is 1, 2, this is 1, 2, 3, 4, 5, 6. So if you could imagine taking this 6.4 and tilting it, that would kind of match this, okay? One more on a map. It says each unit on the map of Lake Okeechobee represents 1 mile. Delia and her father plan to travel from point A near the town of Okeechobee to point B at Pahokee to the nearest tenth of a mile. How far did Delia and her father plan to travel? So it says Delia and her father plan to travel from point A to point B. Interestingly enough, in order to do that, they were going to have to go over water. I assume that we're not being asked to do something like this. So using the distance formula, I'm just going to substitute my x2 minus x1 squared plus y2 minus y1 squared. Then I'm going to subtract. Notice my negative number is staying in the parentheses. And I get 121 plus 676, or 797, which is going to give me about 28.2 miles. Okay, so yeah, remember this is a straight line path, so I'm amused with this problem simply because does that mean we're going to get a boat and we're going to travel across the lake? Maybe, but it doesn't tell us that we're going around the lake, so we assume we're going through it. Okay, now you have a quizzes to go practice. Make sure you practice finding the distance over and over and over again. Make sure you know how to round to the nearest tenth, how to round to the nearest hundredth before you take the quiz. All right, good luck, guys.